Remote sensing in agriculture. In my presentation, I am going to talk about how remote sensing can help farmers. First, let me explain what is remote sensing. It is a technology of acquiring information about the Earth's surface without actually being in contact with it. When sunshine falls on the green vegetation, some part of it is used for photosynthesis by the chlorophyll molecules. A part of the incident light is reflected, which is read by sensors mounted on the Earth orbiting satellites. A number of NASA satellites are busy doing this. The information can be downloaded and interpreted to see if a vegetation or biomass is healthy or under stress due to drought, flood, insect infestations, disease, or any other reason. NDVI and EVI are some of the vegetation indices that provide information of the vegetation health. What are NDVI and EVI? NDVI stands for Normalized Difference Vegetation Index, and EVI stands for Enhanced Vegetation Index. These mathematical equations are used to calculate the indices. NDVI uses the light intensity measured in the red, visible, and near-infrared regions where reflection by green leaves happen. EVI uses an additional band, the blue band, to correct the scatter of reflected light due to the presence of haze in the environment. EVI thus provides a better estimate of the greenness. During my research, I have collected soybean leaf samples from a 40-acre field on a regular basis from 4 field points using a GPS instrument. I have analyzed the leaf samples for chlorophyll content as an indicator of plant health. I also collected NDVI, EVI, and soil nutrient data. I measured plant height and soil moisture content of those field points during the same visit. I plotted these data on the graphs to see the patterns. At the end of the season, when harvest was completed, I obtained the harvest yield monitor data from the farm manager for the same field points. Let me now discuss the results. In my earlier research on a separate field, I found a strong correlation between the NDVI and ground data as shown in this plot. The blue line represents the NDVI index of greenness, and the green line represents chlorophyll concentration measured by a spectrophotometer, which is a ground instrument. Though the units are of different scales, the pattern shows a high concentration of greenness by both scales, showing vigorous vegetation growth till mid-season when the bean pods are maturing. The loss of greenness at the end of the growing season indicates the start of senescence for this crop. This graph shows a summary of the study. A number of parameters are plotted to compare the results found in the 4 different field points noted as points A, C, D, and F. On walking through the field, it was found points A and C were more wet than points D and F. The moisture fluctuation bars are higher at point A and C. Magnesium and calcium contents in the soil analysis show higher concentration at point D. Magnesium is a part of chlorophyll. This translates in high photosynthesis rate and more green in the spectrophotometric and the handheld chlorophyll content index meter. This also translates to higher bushel yield per acre at that point. The pH bars showed that point D also had an optimum pH value for soybean growth near 7.0. Soil pH can be enhanced by high magnesium and calcium soil, often called dolomitic and calcitic limestone. The NDVI and EVI values are also high at points D and F, which also agree with the spectrophotometric data pattern. It is at this stage that I found the strong correlation between the different parameters and the satellite data. In conclusion, my research indicates the importance of remote sensing, meaning use of the satellite data to assess the crop health. Crops' health or stress can be evaluated from these data without the arduous ground sample analysis. NASA satellites collect data every day. This means farmers can monitor crop health as frequently as 2 weeks and take action to address any problem when it happens without delay. Remote sensing can also cut the cost of chemical applications at the unneeded points of the field. The remote sensing method is cheaper, thus can help farmers reduce costs and environmental impact. It can also cut down the cost of scouting for evaluation of field conditions. This is where GIS GPS takes tomorrow's agriculture to a higher level.